In this recording, we demonstrate ARA-to-ICICLE, a remote data sourcing framework agricultural AI processing. The work is a collaboration of the ARA project at Iowa State University, ICICLE at The Ohio State University, and San Diego Supercomputer Center. The primary objective of this work is to demonstrate a new data sourcing modality that enables the live transfer of agricultural data from a remote location to the ICICLE AI pipeline for agricultural analysis. For this demo, we focus on a specific use case, monitoring a remote farm field in Ames, Iowa, using a drone equipped with ARA wireless equipment. The drone captures video of the field and streams it live to the ICICLE AI pipeline at The Ohio State University. The pipeline then retrieves and preprocesses the video, generating geotagged image frames, which are subsequently fed into an AI engine for agricultural analysis tasks such as weed detection. For the demo, we selected a soybean field at Iowa State University's agronomy farm as the site for remote sensing and data sourcing. In the map, the area of interest is shown on the right, marked by a red rectangle. This is where the drone flies to collect sensing data. On the left-hand side is the ARA base station. The drone, while flying over the soybean field, captures video footage and transmits it to the base station, which then forwards the data to the ARA data center and subsequently to the ICICLE AI pipeline for processing. In this slide, we can see the ARA-ICICLE remote data sourcing demo setup. On the left-hand side is the ARA network, and on the right-hand side is the ICICLE setup. The ARA network includes a farm field where a drone is flown for remote sensing. The drone carries an ARA user equipment payload, consisting of a Raspberry Pi 5 connected to an ARDUCAM high-definition camera. The UE also includes a Quectel wireless module, enabling connectivity with the ARA network. While flying over the field, the drone captures real-time video and streams it to the ARA data center via the wireless network. Unlike urban environments, rural base stations are not connected via optical fiber. ARA overcomes this limitation by providing high-capacity, long-range wireless backhaul using millimeter wave, microwave, and free-space optical communication technologies. In the demo, the drone's video travels from the UE to the nearby base station and then through the wireless X-Haul link to the data center. At the data center, a dedicated video streaming server receives the feed, from which ICICLE retrieves the stream for further processing and analysis. This slide provides a detailed description of the drone setup used for remote data sourcing. We use the DJI Matt Rice 600 drone, which supports a payload capacity of up to 6 kilograms. The ARA payload, weighing approximately 5 kilograms, consists of a metal frame, a Raspberry Pi 5 computer, an ARDUCAM OwlSight 64-megapixel camera sensor, and a Quectel RM530 module for wireless connectivity. All components are powered by a dedicated payload battery that supplies 110 volts power. The ARDUCAM camera is mounted at the bottom of the payload frame to capture footage of the agricultural field, while the Quectel module, positioned at the center of the frame, provides wireless connectivity to the ARA network. This slide demonstrates the recording from the ARA-to-ICICLE remote data sourcing session. The video on the left-hand side shows the drone flight at Ames, Iowa, while the video on the right-hand side shows the video processing at ICICLE at The Ohio State University. The drone flew over the soybean fields at Iowa State University's agronomy farm, capturing high-definition footage of the crops and streaming the video live to the ICICLE pipeline. On the right, we can see that the video footage is successfully retrieved at the ICICLE side. The processing scripts then analyze the stream by extracting individual video frames, as shown on the left, and geotagging them using metadata embedded in the video. Once the streaming is complete, the processed data, the geotagged frames, are fed into the ICICLE AI pipeline for weed detection. In the ICICLE pipeline, video frames captured by the drone are processed for weed detection. In this demo, we consider two weed classes, which are shown on the left. The AI engine then analyzes the incoming frames and detects weeds belonging to these specified classes. On the right, you can see the detected weed regions highlighted with red and blue rectangles, corresponding to Class 1 and Class 2 weeds, respectively. This ARA-to-ICICLE end-to-end pipeline enables remote data sourcing from drones, tractors, or agricultural robots to ICICLE AI inference engine, supporting a wide range of applications, including weed detection, targeted pesticide spraying, crop health monitoring, yield estimation, and agricultural phenotyping. Thank you for watching. For more details, please visit arawireless.org and icicle.osu.edu, or scan the QR code.